Welcome to the Radio Amateur channel. In part one of the Biquad series, I gave details on how to make a bidirectional biquad for 446 megahertz using 12 gauge solid wire and a BNC connector. In part two of the series, I'm providing information on how to build a bidirectional biquad for 446 megahertz for outside use. Here is the formula needed to calculate a biquad for 446 megahertz. So to get the loop length or the wavelength, take 11811 and divide it by the frequency in megahertz, which in this case is 446 megahertz. And in doing so, you get 26.48 inches or 67.26 centimeters. The total length of wire is going to be 52.96 inches or 134.52 centimeters. Now to figure out the length of a side, just take 26.48 and divide by 4 and you get 6.62 inches or 16.81 centimeters. To make uniform UHF loops, cut a template the length of one side length of a loop from a thin piece of wood, and I found that a paint stirrer works good. And use the template to bend your loops. Then when you're done, cut off any extra you have left at the end. It's been my experience that the biquad is usually fairly close to resonance, but may require some adjustment by shortening or lengthening the calculated length. So you'll have to experiment a little if it doesn't quite come out perfect SWR. Use an SWR meter, an antenna analyzer, or a VNA to adjust your antenna if you need to. A larger diameter wire will result in a better bandwidth, however it may slightly lower the calculated loop length or the wavelength. Here is a photo of one of the bidirectional 446 megahertz biquads that I made to mount on my tower. And this antenna was one of two that I had mounted on my tower for 5 years, and I didn't have any issues with it. Since it's a bidirectional antenna, make sure that you have the broadside facing in the direction that you want coverage. Now, I made mine using a 30-inch section of 1-inch PVC. Then I made a disc from 1/2 inch plastic cutting board, about 2 inches in diameter, and I used large gauge solid wire. Now I used number 6 because I happen to have some, but you can use number 8 and it'll work fine. And then you'll need 4 feet of coax. Now you can use either RG8X or an RG8 type. Then you'll need a PL259 or a male end connector. And then other things you'll need are some silicone caulk and 2 cable ties. Now, once you have the loop configured, you'll need to notch out one end of the PVC tubing. But before notching out the tubing, take your antenna and line the center wires of the antenna as close as possible at the end of the tube, and then mark with a marker where the wires touch the end of the tube. Then notch out the PVC to fit the wire firmly and flush at the end of the tubing. And you can use something like a Dremel tool or a small round file. But be careful not to notch out too much of the tubing material or the antenna will be kind of wobbly, although you can probably correct that a little by using some of the caulk. Cut a 2-inch diameter piece of 1/2 inch thick cutting board using a hole cutting saw. After cutting the disc, drill a hole in the center of the disc large enough to fit 2 cable ties through the hole. Now, some hole cutting saws already have a drill bit to center the hole, and that may be large enough already to feed through the 2 cable ties. Now, you'll also need to drill 2 holes opposite each other on the PVC tubing about 1 inch or so from the end of the antenna notched end. And that's so you can feed your cable ties through each of them. And then prepare a coax cable by installing your RF connector of your choosing, and then prepare the opposite end with 1 center conductor lead and a shield lead long enough to make your connections. They don't have to be any longer than you actually need to connect to the antenna. Attach the cable center conductor to the top center between the two loops, and then connect the shield to the bottom two free ends of the loops, which will hold them together. And then push the RF connector and the coax cable into the tubing at the notched end, and then press the antenna wires at the center of the antenna into the 4 prepared notches that you made at the one end of the PVC tubing. And then you can kind of check your SWR and make sure it's okay and make any adjustments before completing your assembly. And when you have everything the way you want it, check that everything fits firmly, and then attach the disc to the end of the tubing using 2 cable ties. And then pull them tight and cut off any excess. Then apply silicone caulk to the holes for the cable ties and around the circumference of the disc where it meets the tubing and anywhere where the antenna loop wires exit the tubing. I sprayed clear coat on my antenna loops to prevent weathering. Hopefully this antenna will be a fun project and it'll provide you a bidirectional gain antenna for relatively little cost and time. Thanks for coming to the Radio Amateur channel. Like and subscribe. 73.